Okay, good afternoon. So the first topic that we're going to look at for the year, for grade 9, is going to be exponents. Another word for exponents is indices. Okay, indices and exponents is basically the same thing. So, just to refresh your memory, we're going to look at the laws that we have. We're just going to refresh the laws that was taught you in grade 8. There's one or two deductions that is made in grade 9, but the laws is the same. Okay? A lot of the maths of grade 9 is repetitive of grade 8 maths. It just gets a bit more complex, but nothing really hard. Okay? Very importantly, start working from the beginning of the year throughout, and then you will reap the benefits at the end. Okay? That's my motivational speech for the year. You guys know I don't give much motivational speeches. Right, exponents. And the first topic is rational numbers and number lines and things like that. But we will do that at a later stage, okay? So exponents, indices, 5 to the exponent 3 is also 3 times 3 times 3. There are 5 3's being multiplied by each other. You all okay with that? So if I have 4 to the exponent 2, that is 4 times 4, which is 16. Not so? And so on and so on. So as you can see, there's 5 3's being multiplied. You all okay with that? Just stop me if I'm going too fast, okay? Then, also in grade 8, we spoke extensively about coefficients, bases, indices or exponents. So if you got 2x cubed as given there, this is your coefficient. As you can see, it's the number in front. If there was negative 2x cubed, then what is the coefficient there? Negative 2. Why? Because the sign is part of the term. You all okay with that? Okay. The sign is part of the term. Your base, as you can see here, your base is going to be x, and your index, or your indice, or your exponent is going to be 3 in this case. You all okay with it? Okay. NB, note, the index 3 applies only to x. So if I must extend this to x cubed, that can be written as 2 times x times x times. Can you see that? If I have 2x cubed on the 2, then what is that? 2 times 2 times 2 times. You see that? What if I have 2x all cubed? 2x times 2x times. Are you all okay with that? Okay. The next one. Example here we got is 2 times 3 cubed. If I expand that, what would it be? 2 times 3 times 3 times 3. 3 times 3 times 3 is 27 times 2 is 50. You all okay with that? Okay. 2 to the 3, that's exactly the sum I did now. Not so? Expanded in, what they did was they multiplied the 2's out. Okay. Any confusion at this point? No? At this point, what they did was they also highlighted the following. Okay, we are using the Study and Master Grade 9 textbook. Okay, so 2 to the exponent 2. 2 to the exponent 2 is what? Or 2 squared? 2 times 2, which is 4. And 2 cubed? 8. And 2 to the 4? 16. And 2 to the 5? 2 times 2 times 2, yes? How do you get 25? 2 to the exponent 5. It's going to be 2 times 2 times 2 times 2 times 2. 2 to the exponent 6 is what? 2 times 2 times 2 times 2 times 2 times 2. 64 yes. 2 to the 7.
49.
128. 2. What we do is we just multiply the next number by 2 all the time. There's another 2 being added. That's all. Let's say we got 3 squared, 3 cubed, 3, 4, 3, 5. What would that be? 3, 6. 3 squared is? 9. 27. 3 to the 4? What's 27 times 3? Oh my word! 81? So 3 to the 5. What's 81 times 3? 243. You times that by 3. 729. Seems to the holiday wasn't good for you guys. Why you got a calculator out, Michael? What's wrong with you? Don't play with anything. Okay. Remember that you guys are not allowed to use a calculator. So don't make, when you do your homework as well, don't use a calculator. Because in your exam, you won't be allowed a calculator. So figure out ways of multiplying by doing the calculation. Okay? You guys will be using calculators in terms 3 and 4. Okay? So if you want to buy a calculator in the meantime, buy you one like this. No? Your birthday come around, you tell him, Mommy, don't buy me no present. No doll or... What do you guys get for your birthdays? Spider-Man. Right? You say, we don't want the Spider-Man this year? I want one of these calculators. No? Right. Or don't give me meat for 2 months. No nyama, no? Did I say it right? Nyama. Yeah. No meat. Is that not nyama? Right? No meat for 2 months. So if every day is 20, 2 months you should have enough money for calculator. No? But you guys understand? Right? What if I have 4 squared and 4 cubed? What's 4 squared? 16. And 4 cubed? 64. You guys understand? What if I have 5 squared, 5 cubed, 5, 4? What is 5 squared? 25. 125. So 125 times 5 is 625. Okay? These things you should be able to do in your head. You should have be able to, but you can't. Okay? Also, remember, what is 1 cubed equal to? 1. What is 1 to the 10? 1. What is 1 to the 50? You all okay with that? On the other hand, if I got negative 1 cubed, what is that? Negative 1. Negative 1 to the 8. Positive 1. What's the rule? Exponent, yes? Even, then it's positive, yes. And when the exponent is odd, it's negative. You all okay with that?
Yes, sir.
Right. Looks like we're going to have a good year this year, no? Okay, everybody's quiet here. Negative 1. Are you all okay with that?
Yes, sir.
Okay. Now we're looking at the laws of exponents and deduction. Okay? The first law of the exponents, multiplication law, when we got a to the m multiplied by a to the n. Who can remember this rule? A to the m multiplied by a to the n. Yes. Is a to the mn. You all agree with that?
Yes.
Who says a to the mn? It's wrong. Yes. 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 So it's a m plus n. Okay. Shh. Okay, settle down. So put a box around that. Write that down. That's your first law of exponents. This was done last year. We're just refreshing your memory. Okay? The multiplication law. When you're multiplying and bases are the same, we add the exponents. So next to it, you write down that to that. When multiplying and bases are the same, we add the exponents. Alright, so what's the rule? If you multiply and the bases are the same, what is the base in this case? A. You multiply and bases are the same, add the exponents. So let's look at a few examples pertaining this rule, this law. We've got x squared times x cubed. Write that answer down. Then we have for number 2, we got 2 to the 2 times 2 to the 4. Number 3, you got negative 4 cubed times negative 4 to the 4. Number 4, you got negative 2 cubed times negative 2 cubed. Squared, sorry. And then number 5, negative 2 cubed times negative 2 squared. Okay. Can I start? No? At least the first two? Yes? What's x squared times x cubed? X to the 5. Who got a different answer to that? Right, number 2. 2 squared times 2, 4. 2 to the power? 6. Who got that one wrong? Who said 4 to the power 6? What's wrong with you? Only joking. Okay, that's a common made error. Okay? Remember that when you're multiplying and bases are the same, we add the exponents. That's the only thing we do. So the base remains the base. You understand, my dear? So, like, if you look at this sum here, here's a x, x, x. Can you see that? The base remain the same. So why are you changing these bases here? Can you see that? But I can prove it to you as well why that is correct. Is if you got 2 to the 6, what's 2 to the 6? 2 times 2 times 2 times 2 times 2 times 2. And 2 to the 6 we already worked out to be 64. Not so? So 2 to the 6 is 64. Or I could have said 2 squared. What's 2 squared? 4. And 2 to the 4? 16. 16 times 4? 64. Can you see? Also, if you had said 4 to the 6 is 4096, which makes the answer not good. Makes sense, mate? Any other confusion there? Nobody else? No? So it's 2 to the 6, I can write here, as I said, 60. So since you're not using a calculator, if the number comes to a number over 200, they won't expect you to work it out. Okay, like say for argument's sake, you have 5 to the 6. 5 to 6 is a fairly large number. Not so, they don't expect you to work it out. So that would have been your answer if it's in a test or whatever. Okay. However, 2 to the 6 is fairly small. It's a number less than, okay, let's make it if it's a number less than 100. Okay, and then we'll have to work it out. If it's more than that, the number in exponential form is pass. You guys okay with it? Yes? Sorry? No, now you get the register. School of Australia, they got your register clause, which is with this clause. So we carry on with maths. Okay, so right, so at this point, are you guys okay with that? Alright. Let's look at number 3. You guys finished with number 3? We're still busy with number 3? No? Okay, so what's the answer here? Positive 4 to 7. Who says positive 4 to 7? It's correct. Okay? Why? Because a negative times a negative is a positive. You guys understand? So it's going to be positive 4. And that number 4 to the 7 is fairly large. Not so? So that is suffices your answer. It's okay for your answer. You guys okay with it? Let's look at number 4. Look at number 4. The negative 2 raised to the power 3 times negative 2 raised to the power 2. What's this answer? Is the basis the same as the question? Yes. The bases are the same. Am I multiplying? Yes. So what can I do? Add the exponents. Remember, when you're multiplying and bases are the same, add the exponents. Okay. So what would this be? Negative 2 raised to the exponent. You leave it like that. Or negative to an odd exponent will always be negative 2 to the 5. That's one way of doing it. Okay, and 2 to the 5 is what? We have worked it out already. I think it's 32. 2 to the 5 is 32. What's up? So it's going to be negative 32. Or we're going to say negative 2 cubed times negative 2 squared. What is negative to an odd exponent? Negative. 2 cubed is 8 times negative is positive, negative squared is positive, 2 squared. What's negative times positive? 8 times 4. And there we go. Both ways you're going to get your full multiplication. Okay? Sure, easy it is. Any confusion at this point? Huh? No? Did you guys manage to finish number 5? No? I'll give you a chance to do number 5. Okay, so let's look at number 5. Are the bases the same? For those of you who say yes, how do you get the bases to be the same? What is the base for the first one? -2. What is your base here? It's only 2. Why? Because that square is only on the 2. Can you see that? This cube is on the negative and the 2. That's why you got the bracket there. Can you see the difference? So that cube is on the outside of the bracket. The cube applies to the negative and the 2. Whilst the 2 is inside the bracket. Hence only the exponent of the base 2 and not negative. Make sense? So if the bases are not the same, can I add the exponents? No. So what I need to do is, I need to work out each one individually. So what's negative? Whoops. So what is negative to the power 3? Is it positive or negative?
Negative.
Negative. Can be negative 8 times negative 4. What's negative times negative? Positive. 8 times 4? 32. You guys understand? Or, if you want to use exponents, this could have been negative to the 3, it's going to be negative. Negative to the cube is negative. 2 cubed times negative 2 squared. That's all. What is negative times a negative? Positive. So that will simply be positive. 2. Is this basis now the same? Are those bases the same? Yes. If the bases are the same, what can we do? Add the exponents. So you're going to be 3 plus 2. And what's 3 plus 2? 5. And 2 to the 5 is what? 32. Alright? Any confusion there? Alright, so for tomorrow's lesson we will carry on with the second law of exponents. Okay. You want me to carry on now? You see now why I said we must rather get at other learners here. Because if it was only the 8A's, they never say no, we carry on. But the new learners, we say no, they don't want to carry on. Am I right? Yes. And you don't want to carry on? Or is it just for today? Okay. Alright, you guys can pack up. For those of you who are a bit confused, who want to watch the video again, you can go online and you can watch it later. Okay.